So I try to make a quick. I just trying to do long-term real-world studies for the indoor sanitation, that is toilet studies, and for last 14 months. And that I'm just share with some kind of research that what I found, and also some kind of new application with what we are looking for, the food safety application too. So why toilet is ideal? We have seen many hospital settings, everything, and I know that it's great work and great progress so far. And but toilet study, I think, is also one of the ideal long-term real-life studies, because there are several regions that, because many people using it, frequently using it, and also we know that there are some pathogens available, and also a very moist environment, and also they're related to public health relevance. And also it's kind of a partially controlled environment, possibly like a ventilation and no ventilation, something like that. We can try to control some kind of meaning in that. So this is just case one that we trying to do. So far it's more than 14 months, almost every daily sampling setting. And so we just usually using we originally setting about average using of less than 10% being using at the space of 500 cubic feet, the toilet space. And this is very important. We realize that it should be operating 24 hours per day and 7 days a week, continuously, that is on regardless of the sampling or not sampling. Usually sampling in a day, usually done by the continuous 8-hour integrated sampling, and after that we have a 24 hours incubation from that. We count the bacterial load. Also, we also having not to compare with the other settings, so we have several different locations in the toilets. We have been studying it. So there are 3 other spaces in different areas and different height. And these 3 places we keep about 1.7 microwatt per square centimeter at the position of the sampling area. That's a little bit above than our position with our base position, a little bit above than our base position. And after 24 hours of operation, and that you saw that that is just typical examples of the colony group that we can see. And after the control group and the biopsy group, the control group is also daily basis too. And you can see that the variety of differences there and different setting and conditions, and most importantly, related to human behavior and specific of the use. So in case of the less than average 10 users per day kind of setting, and then we usually using about 40 millijoule per square centimeter dose level per day, not per 8 hours. So it's kind of a low setting. But due to the low consistent use of the people using in the daily basis, and you can think that there's a weekday means that just continues on daily basis. Of course, there weekend we just do control group, or also measuring also sample too. But they usually show consistent value of the reduction in the bacterial count, and average maximum about average 80% or less. And at the time, we didn't use any ventilation. We have a 5 ACH. The fan is installed in the toilet, but we don't use the ventilation because we want to see the only 5BC application. 5BC is the effectiveness itself. And the problem is that after 10 users per day, and more than 10 users per day, they starting to fluctuating the number of the colony groups, the bacteria count, because the loading of the bacteria count is more higher. So even we use 24 hours per day, there's a kind of fluctuation, and there are some kind of patterns can be found. And these patterns that sometimes unusual, or sometimes like a very specific patterns. So we also monitoring why the specific patterns are happening. So what we do is we simply increasing number of lamps, just increase another lamp to make 80 millijoules in the similar orientation level, and then they just start to stabilizing it, and they just continue doing that. But in this case, once the people is using a lot of them, and they have some kind of irregularity in the daily basis, and also average inactivation efficiency about drops down to about 65%. And And with ventilation, without ventilation, we have a room ventilation, 5 ACH. They start showing also very similar range of the effectiveness, but start the number is daily fluctuation we can see. And that's related with the vortex of the water, the airflow inside the room, maybe causing some kind of bacteria in air, and maybe changing the air density level when we do sampling. And after that, after the 10, 20 numbers, it's between the 20, 30 users per day, then suddenly it's almost bacteria count in the control group increasing more than almost close to 200, so it's almost 3 times more higher from the previous values. And suddenly increasing that, and just previous dose levels cannot be operating anymore. So we replaced with the lamp that having a more higher intensity one that we call density lamp, and that making about 432 millijoule per square centimeter per day. And then they just started doing that. They have a consistent pattern like that, like a week to every week, something like that level. And the efficiency achieved up to back to about 80% in weekday level. In the usually Sunday, Saturday, nobody there, and nobody using the toilet, so it's almost sometimes they make a non-detectable. And but I want to talk about a very interesting thing that I observed here that I mentioned earlier, that when they're having we have a 24 hours continuous disinfection in the space, then baseline of a bacteria count and even known people, when the people is using it, then we are expecting the pattern of the bacteria count. And suddenly sometimes there are very irregular patterns and we've observed that more than control groups. And first time we thought that is kind of the technical error, or just maybe sampling errors or contamination issue, but that is continued more than a couple of months in a similar specific pattern. So what we're doing is we do also follow the survey of how the people using it and useful behavior or something like that. And but strangely enough and very amazing enough that what we found is one person makes that happen. So we identified, I don't want to be, it's privacy issue, but one person with a digestive problem has been using a really big kind of longer hours and more uses in the day, in a specific day, then they specifically increasing it. So what does it mean is that when in the control groups, we could not see this kind of pattern at all. When we measure the control group counting every week base, we could not see this kind of pattern at all. But once that we have bio-receipts reduce the baseline of the bacteria count in even every day people using it, then suddenly we can see the specific pattern of some people. So I think this can be a potential. We have a monitoring tool thanks to the bio-receipt for individual or public health. And the air quality part we also mentioned or measured that too. And we saw the every daily based use, so vent is always on. So what does it mean is that we have ozone concentration, VOC level. We could not see that much big difference because in the between and back and forth. And but only see that the big challenge is that it relates to people's behavior when the people many uses enjoy lunchtime, after lunchtime, and then usually have the peak of the VOC levels and formaldehyde too. And interesting enough, but that maximum concentration was less than WHO guideline when OSHA guidelines. And also very interesting is we also monitoring the odor of ammonia-based odor level that is exactly matching with the VOC level. So you can see the right side figure shows that having a very similar pattern with the total VOC level with ammonia level. So that's related to the human behaviors overall on the overall air quality level. And the CO2 level and the ozone concentration level still in the error-based level. Our individual lamp having around the 3 ppb level in the UL867 test level. So we could not see out of too much baseline changing from that in the current setting of measurement. And the food safety part, then maybe we already know there's some papers that maybe there are many different mechanisms of bio-which can do. And so, there are many different pathogens that being used, toxins or pathogens being used for food safety. And usually, but there are different mechanisms applied for the ROS generation, lipid oxidation. O157 E. coli. And those kind of levels, it is because of very important in the national security. In the government, the U.S. government already said as to solve the problem with regard to safety. And we found that it's a very low, even small low doses they can achieve even liquid media, stainless media. They having a very strong sensitivity on that, and so it's very high killing rate up to in a low level of the dose level. And so from going forward, then maybe technically trying to be establishing the tunnel type, the device that we can show the uniform disinfection, because as you know, UV's disadvantage is like in uniform treatment to the food product. So we try to use the BioWish technology to make a uniform irradiation platform. And this platform is a small scale under the program Department of Energy, and we developed a kind of tunnel type and very uniquely engineered so that they are UV transparent tunnel type, because we know the BioWish is relatively safer. So the light is not only the irradiated target, but also emanating to the outside of the tunnel. So that what does it mean is not only causing inside the target surface of a reduction at the left side figures, but also in 8 seconds is already 5 log reduction, and also outside the tunnel, also achieving the bacteria disinfection. And so intensive research has been going on to quality control about what is the effect of BioWish still on the evaluation, and there are some. This is kind of some of the summary that how we're using it. And another part of the food application and indoor application is related to catering area. This also having, we talk about respiratory transmission issue. Also, there's another issue is kind of food safety, the food poisoning issue. So there are several already real-life studies going in that case. And I dreamed about that, how BioWish can be think about just my imagining, and or maybe we can use what is direct using of that. So I asked my idea to the ChatGPT, and the ChatGPT drew that way. and so this is kind of my model drawing, and that's now not being realized. That is one of the company in clean beam in the United States. They're making a boots disinfection tool with this way. Okay, this is my talk about that. Thank you so much.